NCM Learning Center. Good morning friends. In this video, we will discuss about Thevenins resistance calculations for a circuit which have at least one dependent source. I already discussed the various methods of Thevenins resistance calculations. That video link is attached in the description box of the video. Just refer that video. If you refer that video, then the video concepts will be easily understandable. We discussed the three different methods. Method 1 is network reduction method. The network reduction method is only suitable for the circuit which have all the sources are independent source. If the circuit have at least one or dependent source, we cannot use the network reduction method. Method 2 is 1 volt source method. That method is suitable to any circuits and also is easiest one. Method 3 is short circuit method. Okay. Now in this video I am going to solve the three different questions. This question have one dependent source, current controlled voltage source. The question is asked in GATE 2014 instrumentation examination. The second question in this question is asked in GATE 12 Trivia department examinations. This question also have one dependent source. Okay. Third question, this question is asked in GATE 2007 examinations. Is the department questions. This circuit also have one dependent source. Now we will solve the first question. Here the circuit have dependent source, so we cannot use the network reduction method. We can use the 1 volt source method. By the 1 volt source method, the step 1 is we have to turn off all the independent source. Here the circuit have voltage source. This voltage source are independent source. We have to turn off. We have to short the voltage source. If the current source is present, we have to open. Okay. Now the circuits will become, this is turned off, the voltage source turned off. This is dependent source, so we cannot turn off. Okay. Second step, for the calculations of Thevenins resistance at this point C and D, we have to connect 1 volt battery at this terminal. So now the circuit will become like this. Okay. Third step is we have to find the current flow out from the source by using mesh or node analysis. Okay. If you know this terminal, this point, voltage and current, we can easily find the Thevenins resistance. Okay. So now my objective is to find the current outflow from the source, IS. Okay. Here this is 2 loop but have only one node, so node analysis is easier. So we can use node analysis. Let's take node voltage V1. By the node analysis, if you don't know the node analysis concept, just refer this node analysis concepts video. Attach this node analysis concepts video in the description of the video. Now we have to assume current. This potential, node potential is much higher than all other potential, so assume current flow out from the node. Okay. Now find the current by using Kirchhoff's current law. This current, by the Kirchhoff's current law, sum of outgoing current is equal to sum of incoming current. Here there is no incoming current at this junction, all are outgoing current. So this current, this potential is ground potential. So this branch current V1 minus 0 divided by 5 kilo ohm, 5000 ohm. Okay, this is current V1 minus 0 by 5000 ohms plus this current, sum of outgoing current, this current V1 minus 1 volt divided by 5000 ohms. This current. Next, here current is directly given, but this direction is opposite direction, so negative sign. This point is Vx point. Okay, already we are connected 1 volt source, so Vx is equal to 1 volt. Substitute here, you will get the current value is equal to 10 power minus 4. Sum of outgoing current is equal to sum of incoming. There is no incoming current, so is equal to 0. Now find the V1 value by simplifying the equations. We will get 2V1 minus 1.5 is equal to 0. Now the voltage, node voltage V1 is equal to 0.75 volt. Okay, but our objective is to find the source current IS. So IS is equal to, here current flow from this direction. So 1 volt minus V1 divided by 5 kilo ohm, that is IS. So IS is equal to 1 minus V1 by 5000. Substitute this V1 values here, you will get IS value. IS value is equal to 0.00005 ampere. Okay. Now fourth step, we go to find the Thevenins resistance. Thevenins resistance R is equal to V by I. Here V is equal to 1 volt, known value. I is equal to IS, known value. Substitute here, we will get this answer is 20,000 ohms, 20 kilo ohms. Okay, the answer is 20 kilo. Second questions, here the circuit have only at least one dependent source, so we cannot use in network reduction method. By the 1 volt source method, the same procedures. Step 1 is we have to turn off all the independent source. Here there is no independent source. Okay, the second step, we have to connect 1 volt battery at the terminal which we want to find the Thevenins resistance. Here we have to find the Thevenins resistance between the node 1 and 2, so we have to connect 1 volt source between 1 and 2 nodes. So now the circuits will become like this. Here 1 kilo and 9 kilo are in series. Here IB current. Here 1 volt parallel to the 100 ohm resistance. The third step, we have to find the current outflow from the source by using mesh or node analysis. If you know the voltage and current between any terminal, we can find the resistance. Okay, R is equal to V by I. Okay, so here this is loop. If you use mesh analysis, loop 3 number of loops, but the node is single node. Okay, if you consider this node is V1, this node is V2, there is no component between node V1 and V2, so we will get the answer as V1 is equal to V2. So we take as single node. Objective of the node analysis is to find the node voltage V1. But here node voltage is directly given. The node voltage means this point to ground. This point to ground means 1 volt. Node voltage is directly given. So our objective is to find IS. So by using the node voltage, find all the branch current. Then only we can find the source current IS. Okay. So the IB value here, current direction from 0 potential to V1. This current. So IB current 0 minus V1 by 10k. 10,000 ohms. So IB V1 voltage is 1 volt. So IB is equal to 0 minus 1 by 10,000. The answer will be minus 0.001 amps. Let us take this current is IX and this current is IC. IX value 100 ohm is parallel to the 1 volt. So IX is equal to V1 minus 0 by 100 ohms. So V1 value is known values. So IX is equal to 0.01 ampere. Okay. Here IB and IC value is known. IB and IX value is known. Then we can find the IC value by applying Kirchhoff's current law at this point. If IC is known and IB is known, we can find IS. So apply Kirchhoff's current law at this point and this point. In this point, Kirchhoff's current law, sum of incoming current is equal to sum of outgoing current. Here incoming current is IB, but outgoing currents are IX and IC. So sum of outgoing current is equal to IX plus IC. Okay. Here in this point, incoming current is IC plus IS plus 99 IB. All are incoming current. So IC plus IS plus 99 IB is equal to 0. There is no outgoing current, so it's equal to 0. Okay. Now substitute this value. IB is equal to minus 0.0001 amps is equal to IX 0.01 plus IC. So we will get IC value is equal to minus 0.0101 amps. Substitute here IC value. We will get the IS value is equal to 0.02 amps. Okay, now the final step, Thevenins resistance R is equal to V by I. V is equal to 1 volt here. I is equal to IS. Substitute this value, we will get RTH is equal to 50 ohms. So the option A is correct one. Now third problem, the same concepts. Okay, but here independent source 2 ampere. The current source, independent source is there. By the 1 volt source method, first step we go to turn off all the independent source. So here current source, we got to open this source. So eliminate this branch. Now the circuits will become like this. Okay. For the calculation of Thevenins resistance between XY terminals, we have to connect 1 volt battery across XY terminal. That is step 2. Now the circuit will become like this. Third step, for the calculation of Thevenins resistance, we have to find the current outflow from the battery. Okay, IS, by using mesh or node analysis. Here mesh 3 number of loops are there, but only 1 nodes are there. So node analysis concept is much easier than mesh for this problem. So let us take the node voltage V1. For the node analysis concepts, we have to our objective is to find node voltage, but here Node voltage is directly given. Node voltage means this point to ground. This point to ground is directly 1 volt source is given. So node voltage is directly given 1 volt. So V1 is equal to 1 volt because voltage across parallel are same. Okay. So node voltage is equal to 1 volt. Now find the current flow from all the branches. This current V1 minus 0 by 1 ohms. So we'll get I is equal to 1 amps. Let us take this current is IB and this current IC. We may assume the conduction from any direction. Okay. This current IA. So IB is equal to this direction V1 minus 2I by 1 ohms. So I value is known, V1 value is known. So we'll get IB value is equal to minus 1 amps. Then IA. Then IA is equal to V1 minus 0 by 2 ohms. So we'll get V1 is equal to 0.5 amps. Apply Kirchhoff's current law at this point to calculate IC value and apply Kirchhoff's current law at this point and this point we will get IS value. Okay. So at this point incoming current, there is no incoming current, all are outgoing current. So IB plus IC plus I is equal to 0. At this point incoming current, IC and IS are incoming current, IA is outgoing current. So we will get IA is equal to IC plus IS. Okay. Substitute all the values. IB is equal to minus 1 amps, I is equal to 1 amps. Substitute here, we will get IC value 0. Substitute here, then we will get IS equal to IA is equal to 0.5 amps. So IS value is equal to 0.5 amps. Okay. The final step, Thevenins resistance RTK is equal to V by I, V is equal to 1 volt, I is equal to IS. So we will get 1 by 0.5 is equal to 2 ohms. The answers. Okay. Next, do it yourself. The first question is asking Gate 15 EC department examination. The second question is ISRO 2018 electrical department. Third question is Gate 2016 triple department examinations. The same type of question is asked in triple EC and instrumentation. So this type of concept is very much important for triple EC and instrumentation peoples. Okay. The answers for the question is the first one 1.333 ohms. The second question is answer for the second question is 100 ohms. Option A is correct. Third question is 20 ohm. Try comment your answers. Thank you. Thanks for watching. Click the subscribe button and hit the bell icon for notification. Like, comment and share.